Let's use GeoGebra here and let's model this Ferris wheel. We're going to actually put some animation to it with GeoGebra so that we can see this Ferris wheel rotate. And then make sure that you are doing a good job on this and that you have a nice completed example, because we're going to refer back to this later when we talk about velocity. How fast, depending on where we're at here at this Ferris wheel, but how fast is our Ferris wheel rotating? If you're riding on this thing, you may want to go really fast, or if you are kind of scared to even get on a Ferris wheel, you may want it to go really slow. So there can be different speeds, but we want to be able to figure out speed, and so that'll be a later deal. Right now, make sure that you're following along with this video. Make sure that you also have the GeoGebra app up and you're working alongside if you want. Okay, but you need to make sure that you have a completed one done, and you're going to send me a little screencast of your Ferris wheel as an animate so that I know that you did this right. Okay, so throughout these videos I'm going to keep giving you little pointers, little things that I have figured out as I've have been mastering GeoGebra, that's really changed my perspective on this, because there are some things that are kind of hard to do, and if you don't know another way around it, it could be frustrating, confusing, and all that. But I'm going to show you guys just ways that I get around things, and I'll try to explain as I do it. Okay, so the first thing that I want to explain, a little trick of GeoGebra here. Whenever I make a model, I want to see an animation, so I want to hide this picture, right? So if I right click the picture, you get our options like we normally see, and we can click on show object and it'll hide the picture, right? So it's gone now. So if I had my model up here, I don't want that picture anymore because I'm done. I got my Ferris wheel made with GeoGebra. I'm going to click the animate deal and I'm going to watch my model rotate, right? It'll look like a nice Ferris wheel. But right now we don't have that yet, so I just want to be able to hide and show that picture just so that I can keep checking as I'm going, okay? Now here's the hard part about GeoGebra. How do we get the picture back? Because if you look in our algebra window, we only have points that we use to define the picture location. A and B are just corner points. But I don't see the picture at all. So in GeoGebra, the only way right now that we can get the picture back is right-click somewhere in our graphics window. We're going to go down to graphics, the little settings icon there. Okay, then we have to click up, and up here in this window we have some different tabs up here, but this first one's called Object Properties. I want to click on that, and you'll notice another algebra window in this little window, this preference window that pops up. And we can see our points here just like we can see our points in this algebra window. Something that's interesting too real quick is when you select, if I hover over say B, or if I select B, notice it gets selected in this window. There's multiple ways to select objects. So we can either pick points on the, select objects on this window, we can select them through algebra windows, it doesn't matter. Okay? So anyways, the only way that we can get this back is you can see that in this algebra window we actually have an image group and a text group. Because I have my text here, this modeling a Ferris wheel, that's being shown here in this little algebra window. And the picture that's hidden has this little white circle. I want to click on that. It's a little toggle button. So if I click on that, it'll show my picture again. And that's really the only way that we can do that, until I found out about this checkbox option. This third toolbox here, where you probably have a slider tool shown, if you click the down arrow there, one of our tools in this drop menu is checkbox to show and hide objects. Okay, so I'm going to select that tool. Okay, we need to place our little checkbox somewhere, so I'm just going to click somewhere in this white, maybe right here. It's asking for a caption. What do we want to title this little checkbox? So I'm going to call it Show Ferris Wheel. You can say Show Picture, whatever you want. So now what we have to do in this option, the menu just tells us what objects we have right now, and then this little window tells us what we have selected to hide or show, and we have nothing right now. So what I'm going to do is either you can click on image or our picture one here if you want. If you get something that you don't want, there's this little X, this will cancel, so I can highlight this and I can cancel it. But another way to select objects is just click on them in the graphics window. So now when I click on the picture, there's that image, that pick one, whatever. And that's all that we really want to hide or show. So I'm going to click apply. And our little check box comes up here and it's called Show Ferris Wheel. So now when I click on this thing, so I need my move tool. So we'll just select that. If you like keyboard keys, you can hit escape, and escape will deselect whatever we have selected, and it'll default back to our move tool. So anyways, if we have our move tool, let's click the little checkbox and notice now we can hide and show our picture very simply with this little box. Nice little tool to know and get comfortable with. So you'll see them throughout my apps. I'll use them as I demonstrate so that you get more and more practice. So by the end of the year, you should be a GeoGebra Pro. Okay? All right. Let's model this thing here. Where do we even begin? I don't even know what to do for this model. And we want to make this thing so that it's symmetrical, meaning rotationally symmetrical. As this green car were to rotate, let's imagine this Ferris wheel spinning, right? And it's going to go in a clockwise direction, or like a negative angle direction, right? If we talk about rotational symmetry, what that means is as the Ferris wheel rotates around the center, which we can imagine the center point being, you know, somewhere right here. Okay, and we'll find the center point pretty easy here in a second. But if we can imagine this Ferris wheel is rotating around the center. Let's look at this green car here. I don't know why, but it sticks out to me, maybe because it's just on top. But let's use this, and it's going to rotate some angle, right? There's got to be some angle measure between these cars. We'll use these support beams. You know, in our model, we won't have this weird. This is sitting off to the side where this isn't. So anyways, in our model, this will be perfect, our rotational angle here. Each of these cars, we're going to think about as a rotation of the previous one, and we're going to figure out what that angle is. Okay, so this green car is going to rotate to here, yellow is going to rotate to here, orange is going to rotate to here, red is going to rotate, and so forth, right? Rotational symmetry means that there's going to be an angle of rotation where each car is just going to map onto the other car, and everything looks the same. Maybe the color shifted, but the actual shape looks the same, and that's what symmetry means. Okay, now let's look at here. This is a little cartoon picture here of a Ferris wheel. So we can't expect this to be exact. If you were to just grab your point tool, which we're going to use to model the cars on our Ferris wheel, right? And if I just start clicking on here and say, oh, that's good enough, these are going to be my cars, that's not good enough. We want exact, and that's the reason we learn geometry, so that we can learn how to quickly and efficiently find exact points or exact locations of things. Okay. Right now it's a struggle because we're learning properties and we're learning relationships, but once you get practice and you get enough exercise, you can actually start figuring out the geometry and see that it's a lot simpler than just this little guesswork here. Okay. Now, one way to kind of demonstrate this, why it's a bad idea, if we have rotational symmetry, let me show you some things here. I'm going to grab my polygon tool, and what I'm doing is I'm going to make a polygon, meaning a shape with straight sides here that have points as each of these cars. And this is just the eyeball method, right? So let's say we think we're good. That doesn't look too bad. But I'm going to move this polygon over here now. Okay? Now let's look at this thing. If we were to rotate, let's say we knew where the center was. I'm going to grab my pen tool. Let's say the center was right here. And you don't need to follow along with this. Just pay attention and see if you're picking up the logic here. Let's say that that's the center, right? So rotational symmetry means that if we know some angle, right, that's going to get that as this rotates, C maps onto D, D moves to E, E moves to F, F to G, and so forth, and everything looks the same. But if you look at our eyeball method, I don't really think that that's going to happen. I mean, look at, for example, the length of this segment IJ, right here in my picture. Now let's look at the segment, say EF. Those don't look the same, right? If this Ferris wheel rotated some angle and E goes to F, that distance here that gets covered, doesn't it have to be the same distance that I is going to have to do to go to J? But this seems shorter to me, which means if you think about our isosceles triangles, right? Because we're talking rotation, so this point, its distance from the center of rotation must be the same distance that this point is from the center of rotation, which means that we have an isosceles triangle. And the outside of our polygon, this side, that's just the base of our isosceles triangle. Now, if I look at this triangle, this isosceles over here, right, these would have to be the same. But then if these sides are the same and these angles in here are the same, doesn't that really kind of force these triangles to be the same thing? So that means that these bases then, if these triangles are congruent or equal in size, then don't their bases then have to be equal in size? And if we think about it, or if we look at this, they're not. Which means these isosceles triangles are not the same. So that means that maybe this angle here is a little bigger than this one, right? A smaller angle to get I to J, a larger angle to get E to F because it has a little more distance to cover. Okay? So the eyeball method here, even though it might look okay, it's not exact, and we want exact. Okay? So I'm going to go ahead and just get rid of all this, and let's go ahead and talk about how to find exact. So we're going to rotate. You have to ask yourself, what do we start with? How do I rotate? What am I rotating, right? So go back to our definition of rotation and look at our properties of rotations. We need a point, okay? The points are going to be the representation of these cars here. So we need points for cars. And if you count up on this Ferris wheel, there are 12 cars on this thing, okay? So really what we're making is a 12-sided shape or a 12-sided polygon, which is called a dodecagon. So we're actually going to make a dodecagon here. Okay, and those are going to be our points. And we're going to just take one of the points of our shape here, and we're going to just rotate, 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 rotate by the same angle so that it maps here. Okay, so if we have a point that we want to rotate, the next logical question is, well, where do we rotate around? So we need a center of rotation. So I'm going to grab my point tool here, and let's just pick a car to start with. Okay, so since I've been looking at this green one, I'm going to pick this green one here, and I'm just going to place a point somewhere right in the middle of this car. Okay, that's going to be our first car because we have to start somewhere. We have to have a car to start with. Okay, now I want this point to represent this green car, so I'm going to click on it. I don't like this small blue point, so make sure that your graphics window's down. Okay, click this little box or little arrow if it's not. Okay, I want to change it from blue. Since I'm doing the green car, I'll make it green. And then I'm going to try to make it as big as I can. So the next little menu here has a slider of size. I'm going to slide it to the biggest. Okay, it's not the full car, but it represents the car, and that's good enough for me. Okay, so now we have our point. We want to figure out an angle to rotate, but first of all, we have to figure out where we're rotating around, right? So when I look at this picture here, I don't want to eyeball exactly where this center is. And again, it's a cartoon, and who knows if this is exact. But what I noticed, though, is that these beams here, if I follow from this green card down, follow that support beam, notice that that's a nice line all the way down to this one. Which means, really, if you think about it, this car is a 180-degree rotation of this car, right? If this rotates 180 degrees or half of a full rotation, bottom goes to top. So that should be a straight line because remember, lines have an angle measure of 180 degrees. Each point gets rotated 180 to map onto the other side of the line. Okay, so we can go with that. I'm going to use my line tool, and I'm just going to click on a couple points that are on this support beam here. Now I have a nice line. I'll make it a different color to stand out. Make sure that you're doing this because you're going to need to find the center as well. I'll make it red. Okay, so there's one line for the support beam. Now the center has to be somewhere on there, right? Center of rotation, if I'm going to rotate this 180 degrees to get to here, that center must be on this line, okay? But we don't know exactly where yet. But if you think about it, this car is going to be 180 degree rotation to get to this car. So that's a straight line as well. And so I can use my line tool again, and I'm going to make a line that goes along those support beams there. Make mine red again. And now notice the center has to be somewhere on this line too. So if the center has to be on this line and on this line, then doesn't it make sense that where these two lines intersect must be that center point? Because that one point has to be on both of these lines, which is that intersection point. So we actually just found the center of our rotation here. So I'm going to grab my point tool. I'm going to click on that intersection, and it's going to create a little point for us here, the center of rotation. Let's make that stand out a little bit. Okay, let's make it white, and you can make it whatever you want. I'm just thinking out loud. And I'm going to make it a little bit bigger. All right, that's good enough for me. Although white's probably not the best thing. I just noticed as I'm working here, my checkbox is gone. must have deleted that. Sorry, I'm gonna just remake this little checkbox here. Okay, so now when I hide, notice that I have my 2 support beams. This is my green car, right? And here's our center of rotation. Maybe on this white screen, white's not the greatest option. I'm gonna pick brown. Why not? Okay, so we found our center of rotation. Now in our model here, these red lines that we use to find our center, our guidelines, we don't need them anymore. So don't delete them, because if you delete these lines, if I right click and delete, it's going to delete my center because that center depended on that line that I got rid of. So don't delete things. Okay, so now I got that point back. So what we can do over here in our algebra window is just I'm going to click on these little toggle buttons there, and I'm just going to hide them. I don't want to see them anymore. I just want to hide them. Okay, and these points here, these little blue ones, if you look over here, A and B that are not shown, those are the corners of the picture. Okay, but all these other blue points, the only points we really care about right now is this green point that I have, the center point. And we have all these other blue points that we use, that were formed when we made our lines. I want to hide these as well. So in GeoGebra, a quick way to select a lot of things, if I select this, my point D, because it's the top one of my section here, my blue points I want to get rid of, I'm going to select D. I'm going to hold the shift button down on my keyboard, and then I'm going to click on the bottom one that I want, and it's going to highlight everything in between. So now all those points are highlighted. I'm going to right click one of them, and I'm just going to click show object, and it's just going to hide all those extra points that we don't want. So now we got our center of rotation. We have our first car to rotate. Okay, let's put a little logic into this. This car is going to rotate 12 times, since there's 12 cars, right? This car is going to rotate 12 times, and it's going to end up right back to where it started when it's done with that. So if you think about its angle of rotation to get from where it started to end up in the same place, isn't that just a 360-degree rotation, right? Or a full circle, full revolution, 360 degrees. So, and these are equal, by the way, right? So this angle that it rotates to get to yellow, yellow rotates to orange, orange to red, and so forth are all going to be equal in angle measure. Then doesn't that mean that we can just take the full revolution, this 360 degrees, right? That's a full revolution. Since we have equal groups, that's what division is all about. And I'm going to just divide this by how many of those divisions we have. And since there's 12 cars, I'm going to divide this full revolution by 12. And what we should get out then is going to be this angle of rotation here. Okay? What is 360 divided by 12? Let's see, 36 divided by 12. 12 goes into 36. Doesn't it go in 3 times? And since 360 is 10 times as big as 36, this number is 3. We should have 10 times 3 then, right? So that angle looks like it must be 30 degrees. Because if you think about it, we rotate 30 degrees, and then 30 degrees, and 30 degrees, 30 degrees, 30 degrees. If we do that 12 times, what's 30 times 12? Well, 30 times 10 is 300, plus, we have to take the 30 times the 2, right, which is 60. 300 plus 60 is 360. So we know that we did this right. Each angle of rotation's got to be 30 degrees. Okay, so I'm going to hide my pen stroke. I'm just going to delete my pen stroke there. Now we know the point that we want to rotate, the center we want to rotate around, and how far to actually rotate it. Okay, so now what I'm going to do is grab my rotation tool using GeoGebra in our transformation toolbox. I'm going to click on the rotate object tool. Okay, and all we have to do is tell GeoGebra what we want to rotate. So we want to rotate point C. Then we have to tell it where to rotate around the center here, which is my H point, this brown one. Okay, how far do we want to rotate this? Well, we know that if we rotate 30 degrees, since I'm thinking green to yellow, I'm going to go in a clockwise direction. And I'm going to click OK. So now there's my point, right? And again, don't go off this cartoon picture because this isn't exact. We're going to make a model that is exact. Okay, maybe I want to make my point, this green point here, yellow for the yellow car. Okay, and I'm just going to go around the horn here. So this yellow point, if I grab my rotate tool again, now I want to rotate this yellow point around this center. Oops. this yellow point around the center, 30 degrees. It stays in there, that's nice. I'm going to click clockwise again, and now we get this point to rotate here. Let's make it orange. And now I want this point to rotate around the center. If you're clicking and things aren't working the way you want, hit that escape button. It deselects everything, and then just grab your rotate tool again, click on what we want to rotate, where we want to rotate around. Okay, and it's going clockwise, keeping 30 degrees. Okay, now we have this orange one here, which I want to be red, and so forth. So now you can see how we're using this angle of rotation to create this shape. So the next thing that we need to do, I'm going to go ahead and pause this video just because I can see that it's getting long, and I apologize. It's just, this is important that we can do this. I'm going to pause this, and I'm going to have every car on here, okay? So make sure that you have that done as well. Okay, so I use my rotation tool with 30 degrees. Got all the cars here. Notice some of the points are off, but that's okay. If you click your hide the picture, that looks really nice and symmetrical, right? Okay, so now let's go ahead and finish. This doesn't quite look like a Ferris wheel here. So let's go ahead and create our support beams. Let's make this look more like a Ferris wheel. So real quick, grab your circle tool, make your line pretty thick, and I'm going to make my circles silver to kind of match the support beam. So all these circles, these support beams, are centered around the center point. So I'm just going to click on the center point and click on just a point here to make one of our support beams. Okay, and then I'm going to do it again, and now I'm going to do it again, right? Had our picture, see what that looks like. We have 3 circles. These points here, I don't really want those. Okay, so I'm just going to hide those. I'm going to select them all by holding the shift button down, and you can do multiple clicks to select multiple objects, and then just hide them. So there's our support. Now we need to do these beams, okay? So if these are truly 30, 30, 30, 30, 30, 30, there would be, from like this blue car, for example, to get to the pink one, there's 1, 2, 3, 4, 5, 6 rotations of 30 degrees. There's that 180 degrees, right? So that kind of tells us that's a straight line. So all I'm going to do then, just to show these little support bars, is I'm going to use my segments, and I'm just going to connect opposite points. I'm going to make my line thick, just like the circles, and make it the same kind of gray, and connect my opposite points. And notice that center point is going to be selected as well. So I'm going to pause again, and I'm going to make all of my support beams. Also, I might as well make these ground supports to make it look like it's standing up. Okay, so I'm gonna, this will resume in a second with everything done, so make sure you pause and you get your support beams done as well. Okay, my Ferris wheel is supported, right? So I got all the, looks like a little spider web here, nice bullseye spider web. I also put my support beams holding it up there, so now, you know, it looks like a Ferris wheel, right? Okay, so let's animate this thing. So what we need to do is grab a slider so we can slide the angle, because even though it, you know, these rotate 30 degrees to get to each point, we don't want this thing to go 30, 30, 30, 30, because that's not how a Ferris wheel works. We want this to have a nice rotation to it, okay? So let's grab our slider tool. It's in this third toolbox from the right. Click slider, just like the checkbox. We have to click somewhere on the screen to set our slider. Okay, we want this to be an angle. And we're going to go from 0 to 360, so from starting point to a full revolution, and we're going to jump by a degree. We could change this to half a degree, and it'll be a little bit slower and a little bit more exact, but that's okay. A degree is fine. One thing here, when we set our animation, if you click on the animation tab here, you see where it says repeat. We could change the speed. We can actually make our Ferris wheel go faster, slower, and we'll do that when we start playing around with velocity. So make sure again that you have this nice Ferris wheel made, because we're going to use it later. All right, now the repeat here says oscillating, so that means going forward and backwards, going back and forth like this. And what that does is it's going to create a Ferris wheel that's going to go a full revolution, and then all of a sudden it's going to stop and go the other direction. Then it's going to stop and go the other direction. And that's not how a Ferris wheel works. So I'm going to click the down arrow here, and I'm going to click on increasing. So this will go from 0 to 360. Once it hits 360, it goes back to 0 and goes up to 360. And that'll be the way we want this. Okay? So I'm going to click apply. There's our slider, and this is going to be the angle that we want to rotate everything by. Okay, so I'm going to just set it at whatever. It doesn't even matter where it's at right now. This is going to be our angle of rotation. Okay, and as it animates, these points will rotate by whatever that point or this angle is. So now what we have to do is hold the control button down on your keyboard and select all of your cars that are going to rotate. And make sure that all of your points, all your little cars in our model here are selected. They have a little, kind of a little aura looking thing around them. Okay, they're all selected. Now, these points will rotate by this angle, but that's not the only thing rotating. Aren't these support beams that the cars are connected to? They have to rotate as well. Now be careful here, because I use, and I don't know if you did too, but I used the segment that connected endpoint to endpoint, right? These car to car. So when I select this beam here, so you got to hold the control button down still, and it'll just select segments now with our points. Okay, now if I select this segment here and I highlight it, when I go to selecting points around here, I'm going to reselect that same segment down here, aren't I? So that's going to deselect my segment, so I don't want to do that. So really all we have to do is select this segment, this segment, this segment, this segment, this segment, and this segment. And because of symmetry, right, we only have to select half of them because the other half are down here and we don't want to reselect them. Okay, so I think I got everything selected that I want. I can even go down to my segments here, make sure that all my gray segments that I have are all selected, and that's another way to do it. So I have everything selected that I want to rotate. So now I'm going to grab my rotation tool. Oh, and it deselects everything. Uh-oh. Well, let's try this. Dang it. Did yours deselect like mine? Sorry, I don't mean to keep making this video longer. We're almost done here. We're almost at the animation. I'm going to just try these points. Okay, so if I select all the points and I click my rotation tool, they all stay selected for some reason. So I'm going to go with that, and I'm going to click my center point. It's going to ask how far to rotate, and I'm going to delete this angle measure, and we're going to make it this alpha symbol. So I'm going to click on my alpha symbol over here on the right and find alpha. Since it's a Greek letter, it's got its own little box here. So let's go clockwise and click OK. Holy cow, we got some points up there. Right? Now, the last thing that we need to rotate, so if we move our slider around and see what we just created, hey, check that out. Our cars are rotating, right? But we also want these support beams to rotate as well. So again, I'm going to select my segments only by doing half of them. So I'm holding control down, and I'm going to group select half of these. Click rotate the center point. Oh man, is that not going to work? Do we have to do each one of these individually? So I'm going to click on a segment. I'm going to rotate it around the center point. Dang. I love GeoGebra sometimes. Don't get frustrated. Make sure you persevere here. So I'm going to rotate this segment. Get rid of the degree, alpha. Click clockwise. Ooh, now it rotated. So I actually have to do that for all of them. So I'm going to pause again. Also, what I'm going to do is I'm going to hide all my original, my pre-image cars and their segments, so that all that we really see are just the rotating points and segments. So I'm going to hide that. Make sure you figure out how to get that done too, and we'll check our animation and we'll be done. Okay, after a lot of clicking and a lot of frustration there, I got all my original segments and original cars hidden. So now when I slide my slider here, then I can see my Ferris wheel rotating very nicely, right? If we have a little carnival music going on here, right, a little background, this would look pretty sweet. And actually, if we put it on our Ferris wheel, you can see where this cartoon picture not being exact is off a little bit, but we can kind of get this imagination, this idea that this thing would be our rotating Ferris wheel. Okay, so make sure that you get a screenshot. I'm going to include a video of how to do a screenshot of your Ferris wheel animating so that you can get that video to me, and we'll be good. So make sure that your Ferris wheel is nice, because like I said before, we will use this baby for the later activity. Alright, thanks guys.